Hello and welcome to Talk Julia. My name is David Amos.
Hey, my name is Randy Davila.
Today we're recording on May 10th, 2022. This week we're going to take a look at some resources and packages and articles and just stuff from around the Julia community. But first, Randy, you just got back from a little vacation in Mexico and you got to meet someone famous in the Julia community. Could you talk a little bit about that?
Yeah, so me and my girlfriend, we went to Mexico City. And when we were there, I hit up Miguel, the Julia REPL aficionado, I suppose. He was kind enough to show us around the neighborhood where we were staying, and it was great to meet him in person. It's kind of weird that we're still in like COVID times, right? And we don't get to meet all these Julia people that we were interviewing and things like that.
Yeah.
So it was really nice to hang out with him. I hope he's doing well. I hope he's listening. And just giving him a nice shout out. Hopefully I'll go visit him again soon.
Yeah, that's awesome. Maybe that'll be a new quest for us. We'll start doing quests on Talk Julia, where if you come on and join us as a guest, then sometime in the future after that, we'll make it a goal to meet you in person.
Right? I think the hardest would be Bogomil.
Yeah, it'd be difficult, I think, to get it all the way to Poland right now. But I'm sure there'll be some opportunity in the future, whether or not it's in Poland or maybe some other conference or something. But
right. And speaking of, I wanted to let our listeners know that I'm currently trying to get a in-person meetup for JuliaCon at the University of Houston downtown in Houston. It's not set in stone yet, but it's looking like we will probably have one. And we'll keep our listeners updated on this. But if we do get it, I hope to see some faces if you live in Texas or anywhere near to come visit.
Yeah, I hope we can make that work because that'd be a lot of fun. All right, so let's dive into some of the stuff we got here. I'll kick it off with a blog post I came across by Patrick Kidger, and this is a comparison of JAX to Julia and also a little bit of PyTorch thrown in there. So really taking a look at sort of the machine learning ecosystem in Julia, particularly around differential equations. He mentions at first that he was mainly a PyTorch user. It says here, I used PyTorch throughout my whole PhD, but about a year ago, I switched to JAX and haven't looked back. At least for my use case, it's faster and more feature complete. And I'll discuss PyTorch a little bit in this post, but it won't be the focus. And the TLDR here is Julia is amazing, but I'm using JAX. Read on to find out why. So I thought it'd be interesting to talk a little bit about the reasons that Patrick puts out here and also kind of respond maybe to some of the criticisms that he has. He starts out by saying, first of all, he's going to be looking at JAX with this Equinox package for neural networks and compare that to Julia with Flux for neural networks. That's something to really keep in mind. He's particularly using Flux. So some of the criticisms that he has are very specific to the Flux ecosystem and don't apply necessarily to the language in general or to other frameworks that you might use. He says these are really, really similar and both represent models like neural networks in the same way as a tree of modules and parameters. There's a lot of sort of one-to-one maps between different things in the two packages, and both of them are based around just-in-time compilers. Both of them have excellent speed at runtime, and both of them are significantly better when compared to PyTorch for things like scientific computing and differential equation solvers. He mentions, differential equation solvers are quite complicated, and here the overhead of PyTorch's use of the Python interpreter really starts to bite. So this is one of those use cases where the slowness of the Python interpreter actually becomes a real issue, even though I'm sure there's a lot in PyTorch that's written at, in more low-level languages like C++ or something like that. He starts out with, where does Julia shine and where is JAX lackluster? And there's a lot of good things here. So first of all, compilation speed. He says Julia is substantially faster than JAX on this front. He really acknowledges that, the Julia folks have put a lot of effort to really speed up compile times, and it shows. So there's that. Also introspection. So he mentions the tools like the code warn type and code native macros in Julia, which you can use to see how the code is actually being compiled. And that, the closest thing that you get to that in JAX is kind of ugly and not really suitable. And it also prints out, he says, an inscrutable mess of XLA. Arg. So XLA is the backend that JAX translates the code into to be able to officially compile it. So really the introspection in Julia is a real big win for Patrick. And he also likes the fact that Julia is a full-blown programming language, whereas JAX is a DSL. So you don't get all the nice things that you get from just a programming language. And particularly gives an example of how you have to implement like a for loop in JAX as, this long JAX.lax.for_i instead of just using the native for loop syntax. So those are the things that he mentions that he thinks Julia does much better and where it really shines. But where Julia starts to become lackluster, in Patrick's opinion, is, first of all, the documentation. So he mentions that there's something he wanted to do the equivalent of in PyTorch, something called detach, and knows how to do it in JAX, but he could not find it in the Flux documentation. And that's because it actually is part of the Zygote component library. So he had a hard time sort of finding that stuff. There was some shortcomings he found in the Zygote documentation as well. So he says, meanwhile, JAX's documentation is quote unquote fine, sort of hinting that like JAX's documentation is not superb either. He says the clear winner here is actually PyTorch, which has a much better documentation than either of the others. We've mentioned it several times, and I think it's something a lot of people are aware of. The documentation story in Julia is still not complete, and there's a lot of work left to do there, but it is a real issue for users. And if we want more widespread adoption of Julia, we are going to have to really address the documentation issues. And it's also one of those things that just takes time. And, for all I know, I don't know when these particular issues came up for Patrick. The article is from May 3rd of 2022. So at the time of recording, it's just about a week old. But this particular issue may be something that maybe now it's been taken care of, or there's, better coverage in the documentation. But still, it's a familiar story. It's something that I think I agree with, and I think is a big thing that the Julia community is going to have to address going forward. But also that, as someone who is a technical writer, I know that this stuff just takes time and a lot of effort. So it'll eventually get there. The second thing that he mentions is gradient reliability. And this is something I can't really speak to from experience, but I thought it was an interesting point. So he says, I remember all too unfondly a time in which one of my Julia models was failing to train, and he spent multiple months on and off trying to get it working, trying every trick he could think of. And then eventually he found the error, and it was that Julia/Flux/Zygote was returning incorrect gradients. And after having spent so much energy wrestling with that, he was at the point where he simply gave up and he switched back. At the time, it was in PyTorch. And he says now, he would have used JAX. So this sounds like it's, kind of an older thing. I don't know when Patrick switched from JAX to from PyTorch to JAX, but I don't know. This, obviously was some kind of a bug. Maybe it's been fixed by now, and hopefully there was some sort of bug report that got attached to all of this. But I don't know. I can't really speak to that out of experience, but I could see how something like that would be very, very frustrating. And if you've spent that much effort, I can totally empathize with the feeling of just like, you know what, I'm just going to give up on this and switch to something that I know is going to work. The third point that he makes, and this is something that I agree with a lot of things that he mentions here, is the code quality. And he says, okay, so there's the fundamental problem here is that most Julia packages are written by academics, not professional software developers. Academic code quality is famously poor, and the Julia ecosystem is no exception. And he gives some examples. So one is taking compatibility seriously. So he sees lots of things in the Julia discourse where you've got, some library doesn't work, and a maintainer will follow up saying this is an upstream bug in the new version of some other library which we depend on, and we'll try to get it fixed, pushed ASAP. And he says, getting fixes pushed ASAP is great, but what's bad is that the error ever happened in the first place. In contrast, this experience is essentially never cropped up for him as an end user of PyTorch or JAX. So some of that I think is related to just, PyTorch is a very mature framework at this point.
With a lot of funding.
It's had a lot of funding. It's had a lot of users. It's had a lot of time to stabilize. And so, the story may have been different if you're comparing PyTorch at the same time, in the same time frame that you're comparing like something like Flux to. Like, I don't know for a fact, but I do sympathize with this desire for more professional coding. And some of that, again, is just, the audience of who Julia was really developed for and the people who do develop Julia. Not everyone, obviously. And I think that, the core developers are amazing programmers and software developers, but there is a lot of academics that are contributing, and they just don't have the same kind of experience or have had the same needs and really the same problems that software developers who are writing for a more general audience have. So things like compatibility, are things that there are a lot of software engineering best practices that you can implement to get there and things like that. Another thing he mentions is dead code and unused local variables. He says this is something he's seen a lot in even well-known, well-respected Julia packages. He doesn't give any names, but there's like obvious cases of unused local variables, dead code branches, that kind of stuff. And he even says here, in Python, these are things that a linter or code review would catch, and the use of such linters is ubiquitous. I think that's true. Like, in a more traditional software development setting, you're going to have these tools in place that are going to be catching a lot of this stuff, and that just maybe doesn't quite exist yet across the board for Julia. And the other thing is, so the third thing he mentions is math variable names. And this is also a pet peeve of mine. So this is something I very much agree with. And he says, many Julia APIs look like, here you have like maybe some optimizer, and the parameter for the learning rate is the Greek eta symbol rather than, written out learning rate or, something along those lines. He says this is a pretty unreadable convention. So I think, there's arguments two ways here. One is if you're coming from an academic background, something like this is probably very readable to you because that's the way you're used to seeing it in all of the literature. But the end users of these things are not always academics and don't always have the same academic background. And from if you're putting out a package that's expected to be used by many users, I think it's just, this is kind of falls in that self-documentation category where the variable name just tells you exactly what it is. You don't have to know anything about Greek letters or, for certain things, I don't know. Randy is probably way more familiar with the ML literature than I am, but I don't know if eta, I've seen it a lot used for the learning rate and the stuff that I've seen.
It depends.
I was going to say, yeah, there's not always an agreed upon standard for for like symbols.
In the optimization community, the learning rate it's also called the step size, and it's denoted by alpha typically. Whereas in the strictly machine learning communities, I've seen both eta and alpha. So it depends on which academic wrote it.
Right. Yeah. Yeah. So that kind of stuff can be really just confusing, and you can't just look at it and know, oh, there's this eta keyword. Well, what does that do? Whereas if you see a learning rate keyword argument, you're like, oh, I know exactly what learning rate is. I know what should go there. So that is a big pet peeve of mine. On the other hand, though, so I'm not an advocate for removing the use of the Greek letters and the mathematical symbols completely. I feel like if you're solving a problem, so this is you're not writing a library or a package for someone to use, but you're just solving a problem on your own. Maybe it's a one-off script, or maybe it's something that a very small number of people are going to be maintaining, and they're all kind of have the same conventions as you and everything. Then I think using something like, eta for the learning rate, if that's what you use and what everyone else that's going to use this thing uses, then it's, that's fine, because this is not something that's going to be pushed out to be a major framework or something, right? It's just, you're just trying to get a job done. And it's a very quick way to be able to translate maybe something you're looking at in a paper and put that into code.
Also, it makes the line shorter.
Yeah, it does make the line shorter. Yeah. And so that's where, the readability is definitely subjective there. It depends on who's reading it and what standpoint they're reading it from, right? But I do understand this pet peeve of if you're writing a framework, I really agree that you need to go with something like learning rate and not eta. And so it's a pet peeve I also share with Patrick. The other final thing he mentions is inscrutable errors, and this is something I've also experienced with Julia. And again, not just Julia. I mean, there are lots of programming languages where the errors are just almost unhelpful. It doesn't fall necessarily on Julia as a language, that also falls on library authors. And it's something that I think quite often gets overlooked. And one thing I want to mention for anyone that contributes to Julia or contributes to a package that's maybe listening to the podcast, take a look at some of the work that's been going on in Python to work with errors. The last couple of big releases of Python, I think it started in 3.9, has continued in 3.10, and there's some even bigger stuff coming out in Python 3.11, which comes out in October, if I'm not mistaken. There has been a significant amount of work going into improving errors, and they've been doing, I think, a really fantastic job. So I'll link to a few resources, like some release notes, and there's a podcast episode that I listened to with the release manager for Python, for the current version of Python, where they talk about this initiative and some of the work they've done. And I think, they've gotten a lot of feedback from users and have a lot of things to say, a lot of things that they've learned to really improve the errors that you get, to make them more helpful. Because, that's something that I've heard, kind of this argument that like, well, that only really helps beginners. And I think that's patently false. I think having good, clear errors helps absolutely everyone. There shouldn't be some sort of like rite of passage with a programming language of like having to learn how to interpret errors or something like that. And I think, academics that are using Julia should be really familiar with this from all the LaTeX they've had to write. Like, how many times have you gotten a LaTeX error that just like, you're like, okay, something's wrong, but there's no way to even know. It points to some line in your LaTeX file that could be like thousands of lines off from where the actual error is. I mean, there's so many issues with it. It's such a well-known thing. Yeah. Having good, clear errors is really, really important. And then the last thing he mentions, and this is something I don't completely agree with, is the array syntax. So in Julia, if you have like a multi-dimensional array and you do this index, like let's say you have a 4x4 matrix, right? And you do a bracket 1 to get the first element in the matrix. So what this does is, he says, this will implicitly flatten the array before performing the indexing. So if you try this out like in a REPL, if you have like a 4x4 matrix and you do a bracket 1, it'll return the first element in the first row or first column, or whatever way you want to look at it. To get the actual first column, you have to do this a, and then the slice is 1 comma and then the colon, to say that I want everything in that first column. Anyway, this is something he says, this is not functionality I've needed so frequently that it really needed special syntax. However, when I look at this, to me, when I see this, and I'm coming from a Python background as well, and familiar with NumPy and working with arrays in Python, everything. When I see this, where you have the slice of like 1 comma colon, to me, I immediately know that's going to return either like a row or a column or something like that. It just depends on, are we row major, are we column major, like whatever the language is. But that, I see that as being very clearly like communicating that what that is. Whereas if I see this a with just a single index, to me, it's ambiguous what that actually means.
Right. I've seen that a lot, and it's confused me, actually.
Yeah. Like, is it the first row or first column, or is it just a single element? Or so to me, this is actually very ambiguous. So that's something I kind of disagree with. He also says, when slicing, Julia makes copies by default, and you need to use the @view macro to avoid this. This is a silent performance foot gun. I don't know really how I feel about that. If we're talking about things being immutable, or sort of, immutable type behavior being kind of a better default, which in some sense I agree with, then making copies is the right thing to do there. And, explicitly saying I want a view and not a copy, I don't know. I don't maybe have such a strong opinion about that. That to me seems like, yeah, it could be a silent performance foot gun. I guess that's something the documentation has to make clear, though. And then he also finally mentions there's no equivalent of Python's ellipsis operator, the 3 dots, which means something in NumPy, like if you want to get just a single dimension in a multi-dimensional array, then, you can use this ellipses instead of having to indicate so this would be like getting the very last dimension. So the what we have here is a, and then open bracket 3 dots, the ellipses, comma 1 comma colon, and then end bracket. So this is getting the last column, I think, in a matrix. So the example he gives here, you have to use this select dim function. You have to pass it the array. You have to pass it the number of the dimensions that you want, the dimension that you want, and then or actually, I'm sorry, I forget the exact signature of this, but this is another, way how you would have to do it in Julia. There is a different syntax for this. I looked up where you could do a, and then you could do the inside of the slice. You could do like colon, comma, colon, colon, comma, colon, comma, and then you put the one like where you want the actual, like whatever dimension you're actually trying to pick out there, and then followed by colons to the end. Again, I don't have super strong feelings about this. It's just something he brought up as as something that kind of annoyed him. So anyway, that's the article. I know it took a little while to go through that, but I thought it was interesting. There's some valid criticisms there, and he does say like he's not hating on the Julia language. He likes the Julia language, and that his criticisms are primarily of its machine learning ecosystem, not the language itself. And he could see these being fixed with some effort, and maybe in a few years he'll be using Julia instead of JAX. Anyway, I think it's good to highlight these things. It's good for people to put these kinds of things out, especially in a very there's no attack on Julia here. Like there's nothing. It's really just like, look, I use Julia. This is my experience. These are the things I was running into that were difficult for me, and it's very respectfully written and offers some good feedback.
It reminds me of like a referee report, like a good referee report.
Yeah.
On like a paper that you would submit for a journal or something. And this article is actually related to a Julia blog post that I came across right before we started recording. I haven't had time to really read it, so I'm not going to talk too much about it. I'm just going to mention it. It's an article by Chris Elrod, Nicholas Korsbo, and Chris Vakakis. Doing small network scientific machine learning in Julia 5x faster than PyTorch. So this is a new article, so it's 14th of April, 2022. Yeah. And it starts off by just describing that there's like this landscape of major frameworks such as PyTorch, TensorFlow, and Flux.jl that strive for, in quotes, all of machine learning. Okay, so and that's what these frameworks are for. These packages are for. But for specific tasks involving maybe small, like in quotes again, small neural networks that you can run on a CPU, maybe there can be a better design. You can do this faster. And that's what this article introduces, this notion of simplechains.jl. So simplechains.jl is a package written in Julia for these small neural networks that can run fast on CPUs, so like no GPU required, which for me, like in teaching scenarios, is kind of good because I primarily teach with my MacBooks, don't have any GPU support there, so having fast CPU computation on small neural networks like the ones that I teach would be nice. So I was kind of interested as soon as I saw this. And this article, it goes into depth about just kind of performance issues that can happen, and talks about like GPU bottlenecks and things like that. But at the very towards the middle of this article, there's a nice little time comparison using simplechains.jl and comparing this to PyTorch and showing like a vast a 30xing, as they say. So in this tiny example, and I think we'll just put this in the show notes, and hopefully our listeners will go check it out. I haven't had time to really look at it, but maybe we'll do an episode on simplechains.jl at some point and kind of go through and look at actual examples during the podcast. But yeah, so I just wanted to mention that is and then timings against JAX.
So, yeah, there you go.
JAX here, so that's kind of interesting.
What does it say? I think if you scroll down, 10x performance improvement, and on a 36 by, what does that mean? 36 cores, I guess, is what they're saying there. They got some other speed up. So yeah, that actually ties into the 22 times speed up on that, on a 36 core.
Yeah.
And so that actually confirms what Patrick was saying in his article, that compilation speed and just speed in general was a lot faster in Julia than it was even for JAX. So Julia clearly wins in that department.
What else did you have, David? I thought you mentioned something about an inclusive Julia inclusive meetup or something. Yeah,
so I wanted to just kind of do some advertising, I guess, for the Julia gender inclusive group, which I came across a few months ago. They are putting together these meetups. They've had, I think, 3 of them so far, and the fourth one is going to be this Thursday, May 12th. So unfortunately, that'll be before this episode goes live. So by the time you're listening to this episode, this particular meetup will have already taken place. But they're going to be talking about number types, and the series of meetups they're doing is called Learn Julia with Us, and it's hosted by 2 PhD students in linguistics with a background in R and Python. Both of the hosts, Julia and Kyla, also organize R Ladies in Freiburg. I'm not sure if I'm pronouncing that correctly, which I believe is in Germany, to teach statistics. So they're excited to welcome those who use R for data science, those who come from non-STEM backgrounds, and anyone who wants a judgment-free, encouraging approach to learning programming to the workshop. So at this time, these workshops are only open to anyone who sees their gender as underrepresented in the Julia community. That's to actually attend and participate in the workshop. However, they release all of these on YouTube. So once the video comes out, there's on the official Julia programming language YouTube channel, there's a playlist called Learn Julia with Us, and we'll include that link in the show notes, that has the videos from the first 3 workshops. And so this fourth one they're doing on number types, that'll go here, and any future ones will go here as well. So you can follow along. They're done really, really well. And if you're brand new to Julia, brand new to programming, these are great resources to have. They not only go through like teaching you, but they also share a ton of additional resources for you to use. So they're also collecting a bunch of educational resources and then presenting those as well in these. So fantastic place to go to get started with some really nice instructors. And on their meetup page, they've got, upcoming events. There's, the Learn Julia with Us number types, which is coming up on this Thursday. Like I said, that will have already taken place by the time you're listening to this podcast episode. But on Sunday, May 22nd, there is a coffee meeting. And I think they do these every month. They have these coffee meetings. So that's another way to get involved and meet other people, and then maybe see what other events they've got coming up. And that's all they have right now for upcoming events. But they've been doing these workshops about once a month, it looks like, give or take. So definitely check those out. Stay tuned. They have a Twitter account at Julia Inclusive, so you can follow them on Twitter to keep up with the new workshops that they've got coming out and all that. But overall, just a cool initiative. And I like, these workshops that they're doing, and hope that they continue to do those, and more people get involved and continue to grow that initiative that they have. So pretty cool stuff.
Yeah, that's awesome.
What do you got next for us, Randy?
Over the past few months, I've been teaching myself a little bit of reinforcement learning. It's a topic that's always interested me. And I wanted to finish off the spring semester, my machine learning courses. I wanted to show them examples of reinforcement learning, so basic tabular types of methods like Q-learning or SARSA, things like this. The book that I was referencing was this Sutton and Bartow, like really famous reinforcement learning book. It's kind of like the gold standard of all the textbooks. And while kind of trying to teach myself these subjects, I went to reinforcementlearning.jl and started kind of looking around and seeing what that package was doing, because we covered it a while back. But then I kept on looking around, and eventually I found this YouTube playlist on the Julia Programming Language YouTube channel on this package called POMDPs.jl. So this stands for Partially Observable Markov Decision Processes. This is an excellent playlist, and it's related to reinforcement learning in the sense that Markov decision processes are like a very mathematically idealized formulation of the reinforcement learning problem. So when you're going through this Sutton and Bartow textbook, you start basically with MDPs. Because of that, I started watching this playlist and realized that it's great. And I immediately kind of recognized the syntax. So I went to the POMDPs.jl GitHub and just started looking around, went through the documentation, didn't read it too much because that's just how I work, I suppose. I just kind of checked it out, I guess. But then I went back to the YouTube channel and I saw that there is a GitHub page for that YouTube channel. And it's under Julia Academy Decision Making Under Uncertainty. So I just cloned this notebook, this GitHub repository into VS Code and opened up one of the notebooks, and I found an entire lesson that goes along with the lectures for each of these YouTube videos. So I was like, okay, this is great. They're very well documented Pluto notebooks that you can open up. They describe the problem, I guess I should maybe describe that for you. So Markov decision processes, you have an agent and you have an environment. The agent observes the environment, takes an action, and then the environment gives the agent a reward and then transitions to a new state. So on the screen right now, you see S, A, T, R, gamma. So S is the state space, so it's like the collection of all possible states that the environment can be in. So think of like a board game maybe where you have like all possible board configurations for like chess, or that's a lot, right? But maybe something simple like a grid, and you're trying to like navigate through a grid without falling through a hole. So there's all different places that you can be walking in this grid. Action space for like a grid, and you're walking around, you can go up, down, left, right. Transition function, that's kind of a technical thing. It has to do with the probability of actually landing in the next state space given an action. And then the reward function is just how you get rewarded through your agent environment interactions. And again, by you, I mean the agent. And then gamma is this discount factor. We don't need to talk about that. But so as I was going through this, I realized that this is a great package and it's great for teaching. And these Pluto notebooks are definitely great for teaching. But I also learned about a few base Julia things as I was going through this notebook. So for example, in this Pluto cell here, there's a struct that is created. And in the definition of this struct, you have like 3 parameters: size, null state, and p transition. And these are set by default equal to values. Now, I haven't seen that before. And I've worked with structs because they're like the closest thing to like a Python class in Julia. And I've wanted to have default values for the fields of a given struct. Well, you can do that with this @with_kw macro. So this macro allows you to give these like default values here. So @with kw. So the documentation here is kind of meager, but at least it tells you. So it's a macro which allows default values for field types and a few other features. I don't know what those few other features are, but the fact that you can set default types is great. And that's something that I'm sure some of our listeners have wondered about, at least like 1 or 2 of you out there, how to do that. It's with this base Julia @with_kw macro.
Yeah. So I know one of the other features is that it gives you a keyword constructor. So when you actually like create an instance of this struct, grid world parameters, you can say like, size equals, null state equals.
So you can put keywords into it.
Actually put keywords in there, yeah. So yeah, you get the default values, which is really nice, and then also a keyword constructor, which is also really nice.
Yeah, it's awesome.
So yeah, good find. I wasn't aware of that either.
Right. So then like we create this grid world with the size and null state and p transition, and then on my screen right now you'll see like a rendering of this Markov decision process image. So it looks kind of funny because it's rendering in like what is MDP, what is render. These are defined below. So Pluto notebooks kind of work bottom up in a sense. So you have to get used to that. But in front of me, I see a grid. And the goal is so the green squares here are like rewards, and the white squares are like 0 reward, and then the red squares are negative reward. So the goal is to have like an agent placed somewhere in the grid, and then it needs to navigate to the reward boxes based off of a given policy. And a policy is just a way of the agent deciding where to go. If it's like in this cell here, it's going to go maybe that way to the right, go down, who knows? It just depends on the policy. As I go down this Pluto notebook, there's just description like we're building like the state space, the possible states. And then I come across another macro that I haven't seen before. And it's this @enum macro. So David, what do you had a pretty good description of what this is earlier.
Yeah, this is how you create like an enumeration type in Julia. You can kind of think of enums as like a way to create like named constants that are all somehow like related to each other. I don't know that it really creates like a namespace for them in a strict sense, but like in this case, it's got this enum called action, and it's got 4 actions: up, down, left, and right. Now these are really just constants like 0, 1, 2, and 3. So up is 0, down is 1, left is 2, right is 3. And so it's a way to just create like these named constants. Once you have those defined, like, Randy just typed in up into a cell and ran that cell, and you see like the output from that is up : action. So it's telling you that it's this up constant from this action enum, and it's equal to 0. And then you can also do like action parentheses 0, and it'll return that action. So if you're like given a constant, you can find out what it maps to.
It is interesting that the first constant, like up here, is sent to 0 instead of 1.
Yeah, you think of Julia as being like a one indexed language, but I think that's pretty typical of how enums work in any other language as well. So
I kind of read this as like up and then the : action. So it's like up is of type action and its values in the value 0.
Yeah, exactly. Yeah, action is, you're creating like a type here.
Right. And we should say like at enum action, and then there's a code block with begin, up, down, left, right, and then end. You don't have to put these in code blocks. You can put this in one line and it still works.
Yeah, that's a good point. And yeah, it's not a struct, right? There's no struct keyword here.
Yeah.
That kind of threw me off earlier when I first saw it. I was thinking that somehow it was sort of like a struct, and you'd be able to do like action.up or something like that.
Yeah.
But you can't do that. So it's a totally different kind of type. Yeah, and so these enums are really handy because it's a way to make your code a lot more readable, and you don't use these, kind of a common term you hear in programming is like magic numbers, where these like numbers just appear out of nowhere, and it's sort of like, what does this mean? Like, why is this number set to this value? Like, what is going on here? And so you can give it a name, and you can do that with creating like a variable. That's one way to name a variable, right? Like if you have, I don't know, like maybe 3600, that's the number of seconds in an hour. So you could create a variable called like seconds per hour or something, and assign that to 3600. But the enum allows you to sort of group things that belong together, right? So all this up, down, left, right, they're all actions. And then also it allows you to write, so you have now this type action, so you can actually create functions that work on that type. So that's another advantage of using an enum over just like, it could be a function that takes any kind of action. And so you can actually specify with that : right? This parameter takes this type of action and do different things with it. So yeah, very handy.
And then also in this Pluto notebook, we see like this struct called state, which is the XY position in that grid that we were looking at earlier. And we see operator overloading here, which I've needed to do myself. So this is overloading the double equals operator. So base : parentheses double equals. Then we pass in our custom type. So state, state, and then this is what it means here for them to be equal. So if the X value is equal and the Y value is equal, then they're the same state. So it's just, and then you see operator overloading down here as well. So like addition of states. So states are just like pairs, X, Y, right? So if you want to add 2 pairs of states, it's the X values added and the Y values added. So this is just, again, operator overloading with the addition, which is really nice. I do see something, this constant here, which is movements equal to a dictionary, which takes up, down, left, and right, and gives them state values. Interesting that that's defined as a constant. And then here, as you were saying earlier, like here we have our transition function, which is like the probability of landing in a state given an action. And you see here, it takes in a state, which is of type state, right? So S is of type, and then here, A is of type action.
Yeah.
And that could be up, down, left, or right, like you were saying a moment ago. So yeah, then just going down, we see definitions of like the reward function, and we see our little grid again. And then we see a really interesting thing here, which for teaching purposes, this discounted reward notion in Markov decision process with this gamma, you can see on this grid if they're in a given position, depending on gamma. So gamma is like, if gamma is equal to 0, then it's only looking at the reward in the next state. Like, it's just current reward. That it's like kind of greedy. But if gamma is non-zero, then it looks ahead further to like future rewards. Like if it makes this action, finds itself in this state, and makes another action, finds itself in a state, gets another reward, it's looking further down. So if I pull this slider down, you'll see like, so if it's just greedily looking, right, this is just immediate rewards. This is the actions that the agent would take based off of immediate rewards. But as I increase gamma and it's looking further and further ahead, you see that now that the arrows are moving and it's looking like, okay, if I'm here, there's like expected reward to be higher, like down the line, right? So it's not just immediate, it's like down the line. If it goes this way, it's like getting closer and closer over there. So it's just a neat little slider feature. And then here we define our grid world. It's an abstract type. And then our MDP, which we use quick MDP from quick POMDPs.jl. It's just a way of setting up the environment that's very similar to how you would set up, or how I think about it when reading the Sutton and Bartow textbook. And then call some solvers and then solve it. Now, I'm not going to go into the details in today's episode because we're not focusing on this, but it might be nice for us to actually cover the syntax and what's going on here in detail at some point in a future episode. But it's great that these are made for us, right? Like, if you clone this repository here, decision making under uncertainty, you'll see notebooks that correspond to each of the lectures in that playlist that I was mentioning earlier.
Yeah, that's awesome. That's a great find. I guess the other thing it highlights too is like the more you read Julia code, the more you learn about the Julia language, right? I mean, that's true of any programming language, but coming across these little things that you found about like the enum and about the @with_kw, those are things that you might not come across in the documentation unless you happen to be looking in specific areas of it for some reason. Why it's always important to have a healthy diet of reading some code as well.
Right. It's a constant thing, right? Like you have to read every week to like find these little nuances that you've missed. And
yeah,
I enjoy it though. I enjoy learning these new like macros, for example. I don't know. It's a very enjoyable process, but it does take time to like sift through everything.
Yeah. Well, the last thing that I wanted to mention, I'll just go over this really quickly, is a new package from one of our most active listeners, I think. It's from Elias Carvalho. And Elias, I've noticed, it's like one of the first people I see on Twitter that like likes and retweets all of our stuff and comments on our videos, and has just been a really active listener and a real friend of the show. And he's got this really cool little package he's developed called TruthTables.jl. So it's a simple package to create truth tables using Julia expressions. And it was created for educational purposes. Like, let's just take a look at the usage. So it creates, this is really interesting. I'll actually show an example of this. Kind of going back to, you were talking about, overloading different operators. This is actually creating new operators and stuff. So there's some symbols that you can use for these different logical operators. So you've got things for and, or, not, exclusive, or, NAND, nor, implication, and equivalence. And you can actually create these expressions. So like you can use this @truth_table decorator, and then here's an expression, P or Q, and it'll create the truth table for that. So here's P, Q, and then, using sort of the traditional logical like disjunction operator with like the upside down caret, or the looks like a V kind of.
In LaTeX, it's lore.
Okay. It's got like here's the different values for P, here's the different values for Q, and here's what that P or Q evaluates to. Here's another cool one, @truth_table P and then in parentheses, not Q or R. So again, these are not typical Julia operators here. These are things that have been defined in the TruthTables.jl package, and it can print out the entire truth table for that expression. So yeah, lots of little examples here. Here's one with like implication. So P or Q implies R. and what that truth table would look like.
Oh, no, not implies.
Oh, sorry, is equivalent to, sorry. And what's really neat about this is a really fun one to go in and read. So here's where he's actually defining these operators. So for example, the implies operator is like a binary operator, right? So it takes an X and a Y parameter, and both of those are bools. And it's equal to, this is where it's defining the function, the not X, using the typical not, the exclamation point as the not operator, not X, and then the double pipe as the or, which is just the base Julia or Y. So, and that's, that's the logical definition of implies, right? Not X or Y, or not P or Q is the logical definition of implication there. And here, creating like the not symbol, like the logical not, which I don't know how it's the only word I know for that symbol, but it's like a little horizontal dash with a little down at the end. It kind of goes down a little bit, little hook to it. But that not symbol, that doesn't exist in Julia, but here he's creating it as a unary operator. So he creates this, function definition. It takes a single parameter, which is a Boolean, and returns not X using the exclamation point, the actual base Julia thing. So yeah, kind of a cool example there of, creating these different operators and everything. And yeah, and you can just go through and read and kind of see how, he's actually doing all of the creation, the output, all that stuff. So definitely a fun one to just poke around the code and take a look at. But just wanted to highlight that. I think it's a neat little package.
I think I'll use it next time I teach discrete math.
Yeah, it's a nice way to use it in an educational setting as well, right? So for two big reasons. One, to actually talk about logic and truth tables, but then also to learn more about Julia and take a look at the code and how it's working and some cool stuff that's going on there. So great work on this, Elias. I've enjoyed the tweets I've been seeing you put out with some examples of everything that's going on in here. And yeah, just wanted to highlight that and show it off a little bit. So nice work. Yeah, I guess just to wrap up, just remind our listeners that we're working on that in-person meeting for JuliaCon at the University of Houston downtown. So anyone that's in the Houston or I guess Southeast Texas, or if you want to make the trek, if you're from West Texas or something, is certainly welcome to come. But we'll have more information on that in coming weeks. And then one last thing just to mention is if we do have I believe it's pronounced Ko-fi or maybe coffee, I don't know, ko-fi.com. We have a coffee membership where you can support the podcast. If you'd like, you can donate a little bit to that, like a one-time donation. And we also have some memberships with different membership levels starting at $5 a month. So if you enjoy listening to the show and would like to support us and help keep this running and help get us, make us sustainable, then you have that opportunity to do that. We're offering a few little perks based on the membership level. So we'll be releasing episodes early, about 24 hours early, exclusively for members, so they can watch those and listen to them before they come out and become generally available. And we'll also include your like Twitter handle or whatever handle you want, your name if you want your name, or whatever you want there in our episodes going forward. So check those out if you want to support the show. We'd greatly appreciate it. But otherwise, Randy, thanks so much for coming and talking Julia with me today.
Yeah. See you next time.
All right, take care.